So today we're going to look at solving two-step and multi-step inequalities. So look at example 1. You're going to solve and graph the solution. So I apologize, I still have a cold. So draw your line, and we have to isolate the 4f. So we want to get rid of the 160. So we're going to subtract 160 from both sides. Bring down the 4f. And that's less than or equal to 500 minus 160 is 340. Then to solve for f, we're going to divide by 4. And nowhere did I multiply or divide by a negative, so I'm not flipping the sign. And I end up with f less than or equal to 4 times 8 is 32. And 4 times 5 is 20. So 4 goes into 340 85 times. So this is the solution to the inequality. So our boundary point is 85. I'm going to put that in the middle. And I'm just going to label every other hash mark. That way they don't get all squished together. Because it's less than or equal to, we are going to have a closed circle at 85, and it's less than, so an arrow to the left. Example 2. Draw your line. This time we've got to isolate the negative 2t, so we need to get rid of a positive 7. So we're going to subtract 7 from both sides. Then we bring down a 2t, less than or equal to 21 minus 7 is 14. Then we're going to solve for t by dividing both sides by a negative 2. So warning bells should be going off in your head. Because we just divided by a negative, we're going to flip that inequality sign and make it a greater than or equal to sign. So the 2's cancel. We get t is greater than or equal to negative 7. So there's your solution. Our boundary point is negative 7, so that goes in the middle. We're going to have a closed circle at negative 7 because of the equals to. And it's greater than, so we have an arrow to the right. Then simplifying before solving just implies that you're going to have some collecting of like terms, maybe the distributive property, maybe a power to a power. So perhaps some things to do other than just moving terms. So for example 1, as you look at the left, both of those are like terms because remember numbers are like terms. So a negative 4 plus a negative 8 gives you a negative 12, less than, we cannot do anything on the right, so take that away. So we've got a negative 5c minus a 2. Now we want to get the c term by itself, so we want to get rid of the minus 2. So we're going to add 2 to both sides. A negative 12 and a positive 2 is a negative 10, less than negative 5c. To solve for c, we're going to divide by negative 5. Because we are dividing both sides by a negative, warning bell should be going off. You're going to flip that inequality sign from a less than to a greater than. Negative 10 divided by negative 5 is a positive 2. The 5's cancel, and so you get 2 is greater than c. For graphing purposes, we like to have c on the left. So remember from class, we're going to play that Vanna White. We're going to flip the left and right side of the inequality, and when we flip the left and right side, we also have to flip the inequality so it goes back to being a less than sign. So our solution is c is less than 2. So our boundary point is 2, and then label every other one. We're going to have an open circle at 2 because there is no equals to, and c is less than, so that means we have an arrow going to the left. Example 2. Draw your line. On the left side, we can actually distribute the negative 3 into the parentheses. So when we do that, negative 3 times 3 is negative 9. Negative 3 times a negative x is a positive 3x. Less than, and then on the right, we can actually take 4 squared and replace it with its value. 4 squared is 4 times 4, which is 16. So now we're back to solving the regular inequality, so we want to get that 3x by itself. So we're going to get rid of the negative 9 by adding 9 to both sides. So bring down the 3x. That's less than 25. 16 plus 9 is 25. Then to solve, we're going to divide both sides by 3. Don't let it bother you that 3 does not go into 25 evenly. Your answer is indeed a fraction, so it's less than 25 over 3. For graphing purposes, I like to look at this in terms of its mixed number. So 3 goes into 25 8 times, 8 whole times. 3 times 8 is 24. That leaves 1 left over from 25, so it's 8 1/3. So what I would do is put that right here in the middle, 8 1/3. And then because your denominator is a third, or 3, partition this number line into thirds. So if this is 8 1/3, this one right here is 8 2/3. This is 8 3/3. Well, 8 3/3, 3/3 is 1, so 8 plus 1, this would actually be 9. And so this would be 9 1/3, 9 2/3, 9 3/3. Well, 9 3/3 becomes 10. So every third hash mark is a whole number, and so if I were you, I would label every whole number. So here, if we go backwards, if this is 8 1/3, subtract a third, this right here must be 8. And then count backwards. 1, 2, 3, this right here must be 7. So we're going to put an open circle at 8 1/3 because that's our boundary point. X is less than 8 1/3, so we have an arrow going to the left. That's a really terrible arrow. There we go. It's a little bit better. Example 3. So this one's fun. It's a fraction. Remember how we get rid of fractions? We look at the least common denominator. So if I were going to take 5 and 2, which are two different denominators, and make them into the same denominator, I could convert them both into 10. If you can't easily find the least common denominator, then just multiply your different denominators together and make that your least common denominator. It won't actually be your least common denominator, not always. In this case, it happens to work out. Where's my pen? So my least common denominator is equal to 10. So I've got to multiply each and every term by 10. Not just the fractional terms, but every term. It just so happens that every term here is a fraction, but even if they weren't, I would still multiply them by 10. So for the first one, 5 goes into 10 twice. So 2 times 4 is 8, times x is 8x. Then for the second one, 2 goes into 10 5 times. 5 times 1 is 5, so I get a positive 5. And then the inequality sign does not change, so it's still greater than. And then for the last one, 5 goes into 10 twice. 3 times 2 is 6. And then we have just a regular inequality that we're going to solve. So we're going to get the, let me get my colors back. We're going to get the 8x by itself. So I want to get rid of the plus 5, so I'm going to subtract 5 from both sides. I end up with 8x is greater than 1. When I divide by 8, we do get another fraction answer. So x is greater than 1/8 is our solution. So that's going to be my middle boundary point, 1/8. And because my denominator is 8, I'm going to count by eighths. So for instance, if I do 1 to the left of 1/8, wouldn't this be 0 right there? And if I count, I've got 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and then, so I'm going to leave that one as 6/8. Normally I would just label every whole number, but I'm running out. And so from 0, I've got -1/8, -2/8, -3/8. This will be a -4/8. All right, so at our boundary point, we have an open circle because there's no equals to, and it's greater than, so we have an arrow going to the right. Then the last problem is a word problem. So remember, with word problems, we always want to use the 4-step problem-solving plan. So let's read it. It says, to win the blue ribbon for the heaviest pumpkin crop at the county fair, the average weight, and that's key, that they're using that word average weight, so you have to be able to find the average between 2 pumpkins. So the average weight of John's 2 pumpkins must be greater than, another important word, or word phrase, 819 pounds. One of his pumpkins weighs 887 pounds. What is the least number of pounds, so the least number of pounds, the second pumpkin could weigh in order for John to win the blue ribbon? So let's look at what it is we don't know. So the question says, what is the least number of pounds the second pumpkin could weigh? So that's our unknown. I'm going to let x equal the number of pounds of the second pumpkin. And then just for chuckle's sake, because I like to put extra things in my let statement if I have it, I'm going to let the first pumpkin equal 887 pounds. So now I know that my first pumpkin is X. I'm sorry, my first pumpkin is 887 and my second pumpkin is X. We want to find their average weight. So to find their average weight, you would add them together, X plus 887, and you would divide them by 2 because we have 2 pumpkins. Our inequality sign is going to be greater than. It says greater than 819. So that average weight must be greater than 819 pounds. So let's go ahead and get my calculator brought up here, run these through the numbers. Okay, so to get rid of my fraction, I want to multiply both sides by the denominator. So in this case, the denominator is 2. So I'm going to multiply the left and the right side by 2. That way those cancel. And I get x plus 887 is greater than 1638. Then to solve for x, I'm going to subtract 887 from both sides, and I get x is greater than 751. Is that right? Let me double check. Yep, 751. So that means that my second pumpkin has to be greater, has to weigh greater than 751 pounds for their average weight of the 2 pumpkins to be greater than 819 pounds. So to answer the question, therefore, answer the question in a complete sentence. What is the least number of pounds the second pumpkin could weigh? Therefore, the second pumpkin must weigh more than 751 pounds. And here's today's assignment. Have fun.